Now, as we discussed earlier, that the service area of a mobile network or a mobile operator is divided into the MSC areas. As many MSCs there are in a mobile network, uh, there are as many mm, mobile service MSC areas. Now each of these MSC areas is then further subdivided into location areas. For example, here one MSC area is further subdivided into location areas, and location area 1, location area 2, location area 3, and location area 4. And each of these location area can be made bigger or smaller. If it is a bigger, then you have more base stations in it, and if it is smaller, you have lesser base stations in it. Now, what are the implications of having bigger location areas and smaller location areas? If location area is very small, it contains one or two base station. In that case, whenever a mobile station will leave one location area and go to another location area, it would basically notify the network that it has changed its location area. So if the location areas are very small, there would be frequent location area updates, and the signaling load on the network would increase. On the other hand, if you go to the other extreme and location areas are made very big, in that case what would happen? Now when a mobile is in idle state, that means it has registered itself with the network earlier, but it is not in a call. In that case, the location of a mobile is known to the resolution of a location area. That network knows that my mobile is in this location area, but the network doesn't know that it is in the area of which base station. So what would happen then? In that case, if there is a mobile for a there is a call for a mobile, for example in location area number 1, then the network needs to page all the base stations in that location area. So in that case also, the signaling load of paging on that location area increases. So our purpose is to reduce that signaling load. So the size of location area is a compromise between the paging load and the location area update signaling load, and we come up with intermediate sizes so that we have less signaling for both the location area update and the paging in case of a call. Now, how these location areas are identified? These location areas are basically, each of these location area is given a location area code. The location area code makes these location areas unique within an MSC area. But you know that mobile stations also roam into other operator areas or into other countries. So you have to make these location areas unique globally so that roaming is possible. So what you do is that you add the fields of mobile network code and mobile country code to the location area code, and this makes the location area code is now called with the addition of these two fields as location area identifier, and this location area then becomes unique globally thanks to location area identifier. So here to summarize up, that location area comprises of one, and it can comprise of many base stations, and the purpose of defining these sizes is that we have less signaling load for the paging when a mobile needs to be paged for an incoming call, and we have less load for the case when you have location area updates, means a mobile moves from one base station to another one location area to another location area, and it updates its location area information to the network. So we come up with an intermediary size of location area so that these two signaling loads are less. And this location area is basically broadcasted when you talk about the base station in the uh, broadcast channel, that is the BCCH channel. On the BCCH channel of a base station, its location area identifier or location area information is broadcasted.